So now let's go to MATLAB and start working with our transfer function. So we start by building the transfer function, which is 1 over 10s2 plus 11s plus 1. And then we will start the SISO tool, or which is a control system designer. Okay, so on the control system designer, we'll start by looking at the architecture of our system. So this is what we have. This is our transfer function, which is mainly the feed forward transfer function. C, it is a controller that we want to generate or that we want to compute in this exercise. F here we will get it 1, so F mainly it is used just to change a little bit or to do a unit conversion between the input and the required input. And H, of course, it's taken as 1. So we can change the configuration or the architecture of our system, but for the moment we will keep it as that. And we'll be from the responses we'll be choosing this one, which is related to the closed loop transfer function. If we look at the plots that we have, so we have the body plot of the system. This is the magnitude and this is the phase. We have the root locus of the system. Of course, the body plot is applied to the open loop transfer function. The root locus will show the closed loop transfer functions, the closed loop, the poles of the closed loop transfer functions. And we have here the step response. So the first thing that we need to set is, as we said, we need to insert a proportional corrector to our system in order to have an error of 0.01. So if I look here at the error, I can press here on the step response and I will see that the amplitude is 0.5, so it means that the error is 0.5. So I need to add a corrector to my system. So the corrector, we know it is effect on the body plot. It will only raise the magnitude plot. It will have a phase of 0 and it will only make this magnitude plot to go higher. So what we'll do, we will drag our magnitude plot up, and by that we are increasing the gain of our system. So now I have added, let's say, 15 decibels as gain to my system. I can come to here, I can check the output. It is now, the steady state output is 0.84. So it means that I am now around here 0.15 error. I can see that the roots of my system moved. So these two magenta plots are the root of my system. And of course, the phase plot did not change. So I will continue by dragging up my magnitude plot in order to reach here 0.99. So I will increase it a little bit. And now I have here a steady state output, which is equal to 0.99. Okay, where I have an error of 0.01.